All right, you know the drill. So this one, our lesson is 4.05, dilations and the coordinate plane. Definitely need your math notebook and something to write with. Probably don't need a calculator today, but please make sure you are prepared and ready for the lesson. All right, we'll go ahead and get going. So our essential question is, what is a dilation on a coordinate plane? Today, I will use math vocabulary to describe transformations and explain the effect of those transformations over the x or y axis using algebraic representation so that I can determine the algebraic rule for the dilated object. I will know that I got it if I can analyze the given information to determine the rule. So this will be a little introduction to the rules for dilation. We had a previous lesson was the intro to dilations. We talked about the scale factor. When it goes from small to large, the scale factor will always be greater than 1. When it goes from large to small, then it's going to be less than 1. And like I said, we're going to have a preview of the algebraic rule for today, and we'll go in more depth on the next lesson, 4.06, with that. So here we go. So this is a review. Hopefully you remember this from yesterday's lesson or the previous lesson. So you should have this in your notes already. I'm not going to go over all of this in detail. So main thing, remember that the scale factor is the new side over the old side. And if it is greater than 1, it is enlarged. If it's less than 1, it is reduced. And so from new to old. So let's look at the algebraic rule, what it looks like. It's taking the x, so here's the original one, and then you actually take the scale factor and you multiply the x coordinate and the y coordinate. So it's a pretty easy one. So we have our example here, the new one, or sorry, the old one's here, B, C, D, and here's the new one. Remember, you can tell because it says the prime. So if we look here, this is, just use any two sides. This goes 1, 2, 3, 4, 5, 6. Now this one's easy to see that it's 6, and then this is x is 3. 1, 2, 3. But you can also use the coordinates, like if we look at going from A, or let's use B. So this is our old one. The 4 goes from 4 to 2, so it's reduced in half. So that is our scale factor, 1/2. The y value goes from 4 to 2 as well, so it's reduced to 1/2. You can use any of the points and see that is the same scale factor. So the algebraic rule for this one would be 1/2 x, comma 1/2 y. Each the x and y coordinates are multiplied by 1/2, the scale factor. So let's practice a little bit. So it says write an algebraic rule to represent the transformation. Our original one is here, and it goes to this one. On this, it's pretty easy to look at the sides. We're going to do it both ways. So the length of this the old one was 2, and then the length here goes from 2 to 1, 2, 3, 4, 5, 6. So 2 to 6. So the new one is 6. Old is 2, which is 3. So the algebraic rule, and we start with our original x, y coordinates, and we multiply each of those by 3, our scale factor. If you used a point, let's just look at P. P is at 1, 3, and the new one is at 3, 9. So looking at the x values, 1 changes to 3, you multiply by 3. 3 goes to 9, you multiply by 3. So there's our rule. All right, so this was a star question. Triangle TRW is shown on the coordinate grid. It says the triangle will be dilated by a scale factor of n with the origin as the center of dilation to TRW. Which order pair best represents the location of point R? So don't get hung up with them, telling you all of this, but just focus on what they're telling you about the scale factor n. So you've got the TRW and a scale factor of n with the origin as the center of dilation to create TRW. One thing we don't know if n is positive or negative. So what you're looking for, scale factor is always going to be multiplied. So this is out because it shows division. This shows plus, this shows minus. So the answer would be G. That one was a little tricky because of it being the opposite. All right, let's go ahead and look at another one. This was a STAR question actually from last year. This is the newest STAR test. So we have a table that shows the coordinates of the vertices of a pentagon, A, B, C, D. So these are all the coordinates because pentagon has 5 sides, 5 corners. So this is all of our corners. It's dilated by a scale factor of 7/3 with the origin as the center of dilation to create the new one. If XY represents the location of any point on the pentagon, which ordered pair represents the location of the corresponding point? So our scale factor is 7/3. So that has to be what we multiply both the X and Y value by. They try to make it really wordy to confuse you, but you're just focusing on the correct fraction here being multiplied. This one, they flipped it, so that makes it wrong. And the other two show that you're adding. All right, this one was also a STAR question from last year. So quadrilateral PQRS is the original one, is dilated with the origin as a center dilation to create the new one. The coordinates of each vertex are integers. So if you look, this is at an angle, we're going to have to use the points here. So we've practiced a couple like that. So let's go ahead and just use P. Our original one is at, what is it at here? -4, 12. And the new one is at -2, 6. So remember, it's new over old. The new one is 6. The old one is 12. We can use any of the coordinates. It doesn't matter. And even if you did the -4, -2, you're still going to get this as 1/2. So let's look at our answer choices. And all I did here was use the Y values. I mean, you can use the X values as well. The X values would be the -2 over -4, which also simplifies to 1/2. So using either one works. So each side length of quadrilateral PQRS is half the corresponding side length of the new one. So be careful with that. The half is correct, but they're saying that the original one is half the size. The new one is half the size. So that's not correct. For B, the new one is congruent. Nope, not going to be congruent. Remember, it's going to be bigger or smaller. Each angle measure of the quadrilateral PQRS is half the corresponding angle measures of the new one. The angle sizes do not change. So here's a new one to throw at us. This is actually the answer. They're similar. You have to remember what similar objects are. They're the same shape, but not the same size. And the angles will always be the same size. The corresponding sides will have the same ratios. So dilated objects are also considered similar. Last one, and this was also a STAR question. The coordinates of the vertices of triangle XYZ are given -2, -1 for X, 6, 8 for Y, 8, 4 for Z. The triangle XYZ is dilated by a scale factor of 3/2, with the origin as the center of dilation to create the new triangle. If XY represents the location of any point on the original one, which ordered pairs represents the location of the corresponding point of the new one? Here's our scale factor. It just has to be multiplied by the X and the Y. So it would be A. B is being added. This, they flipped on C, and that's also incorrect. Please make sure you complete the OMIS lesson. If you have questions, reach out to me.